So, hi and welcome everyone. Welcome to the presentation titled Security and Privacy in 5G and Beyond Wireless Networks. We know we have many generations in wireless networks from the perspective of cellular systems. We have the first generation, the second generation, the third generation, the fourth generation. We are currently in the fifth generation. And researchers and the standardization bodies like 3GPP are now working on preparing the sixth generation, 6G they call it. So what are the topics that we are gonna talk about here? We will introduce you to 5G, give you a brief overview about this system, and then talk about 5G security, mainly pre-5G security issues. What are the issues before 5G? Security impact of network softwareization in 5G, security issues related to new technologies, security issues related to new verticals. Then talk about network softwareization for 5G security and network monitoring in 5G. And finally, discuss 5G privacy, 5G user privacy, 5G privacy issue, 5G privacy objectives, and the privacy protection schemes and mechanisms. And as we can see here in the slides related to comparing the different generations we have in mobile wireless cellular systems, we have the first generation which was introduced in 1980s, and it was responsible or was aiming for just sending and receiving analog voice. And the systems, this generation was introduced to the market under different names like AMPs, NMT, tags based on the country that was used in, whether it's in US or Japan or Europe. And then after that, we had many problems with analog voice. You couldn't serve too many users. You have limitation in the number of users you can serve. And it was an encrypted transmission, and it was completely analog. In 1990s, in the 90s, they introduced digital communication system, TDMA, time division duplex. Oh, and for the first time ever, you are now able to serve more calls with less bandwidth. And messaging, SMS, was first introduced around that date, 1990s. And the data rate was less than half megabit per second. And the names given to this generation were GSM, GPRS, or CDMA1 or D-amps, digital amps. After that, in 2001, we had the 3G mobile network, which were able to provide like around 64, 63 megabit per second. And the main service was mobile broadband, improved the internet speed basically. And the names of this technology went to the market under CDMA 2000, EF-DO, WCDMA, HSP Plus, TD-SCDMA. So these are different marketing names for the same technology, but they were used in different countries. And one point to mention here, this is the technology that we currently use in our phones, 3G for connecting to the internet. And after that, in 2010, we had the mobile 4G LTE, and LTE Advanced. These are the names of the commercial names of the technology in the market. And the main goal was to provide even faster and better internet connectivity. So 4G is not yet used in right now with your mobile. Many mobile smartphones are supporting it, but it's now an old technology because it was introduced in 2010 and now we are in 2025. But it's not being used in some regions in the world, unfortunately, because of some political, geopolitical, or economical problems. I don't know the main reasons, but it's not being used in some parts of the world. And after 4G in 2020, We had the 5G. 5G is even promising further improvement in the in the data rate up to 1 gigabit per second, uplink and downlink 10 gigabit per second, and lower latency, better reliability, and many more innovation. So what's the ecosystem of 5G? We have the electricity grid, and these are connected to towers that provide 5G connectivity, and these 5G connectivity towers are providing e-health, smart parking, smart mobility, smart wearable, car-to-car communication, water quality, utility management, and so on. So these are the different applications and services that make use of the 5G connectivity technology. And if we were to classify these applications, they can be classified under many categories like energy and utilities, manufacturing, public safety, healthcare, public transport, media and entertainment, automotive, financial services, retail, and agriculture. And there was an estimate that the number of 5G enabled industry digitalization revenues for ICT players will be more than 1 trillion. What are the new applications or new smart devices that are making use of the 5G connectivity and benefiting from it? We have something called autonomous self-driving cars, like the car connected to a low latency, high-speed 5G network, and the commands are sent through the 5G network to avoid delay. We have wearables to measure and sense things and send them on time. Real life, we have industrial internet, factories being built, the robots inside the factories being built while uh, being built based on the 5G technology because of its many characteristics, including low latency, high reliability, and faster data rate. We have drones and UAVs using the 5G. We have remote surgery applications. We have also some other applications related to just more data rate and better internet speed, like the 4K, 8K video, the hologram TV in the air, and the augmented reality, virtual reality kind of application, which require extensive high-speed internet with low latency, of course. So the 5G requirements, what are they? So we have mobility, we have latency, we have connection density, we have network energy efficiency, we have area traffic capacity, and we have data rate, peak data rate. So the one in uh, the inside shape here is for 4G LTE network, and the one here is the outer shape, the blue. The blue over here is for 5G. So we have 4G and we have 5G. And this figure compares between them in terms of different metrics, like the peak data rate, the area traffic capacity. Now, if I ask you from this figure, what's the maximum data rate that 5G can provide in downlink? Peak data rate, you tell me, I can look into this figure and I can see it's 20 gigabit per second. And for 4G LTE, what was the maximum data rate? For GLTE-A, which means advanced, the maximum was 1. So the improvement in data rate is 10 more than 20x. But like usually, the data rate improvement goes from 10 to 20 gigabit per second. And if we look into the latency, what's the latency of 5G? 5G here, latency is 1 millisecond, while 4G is 10 millisecond. And what about connection density? For 4G, it was like 1,000 device in 1 kilometer. In 5G, you have almost 1 million device in 1 kilometer. The mobility, 4G was able to handle a speed, provide connectivity to a device that's moving with a speed of 350 kilometer per hour, while 5G was able to provide connectivity for a device that's moving with a speed of 500 kilometer per hour, like almost close to the plane speed. This is very fast. So the enabling technologies here, okay, we have nice requirements, we have nice key performance metrics, uh, like unbelievable, the improvement, the enhancement with respect to 4G. 5G is way better, way much stronger. But like, what are the enabling technologies? How were we able to provide such performance? So the enabling technologies are mainly new spectrum. We have opened up more spectrum, new that can reach in the millimeter, that can work in the millimeter wave range. We have we have the massive MIMO technology. We have the multi-connectivity with 4G LTE and Wi-Fi simultaneously. We have flexible frame design, clean carrier, flexible size control, TDD bandwidth, and distributed architecture. So the technologies mainly are more bandwidth, more antennas, much stronger framework, waveforms, and distributed architecture and network softwareization and virtualization. Now, this statement says the improvements was done not just in the radio technology, but also in the core network. And the core network of 5G is different from 4G in the sense that 4G had just five major components like the user equipment, the eNode B, the gateway, the MME, mobility management entity, and HSS, home subscriber service. In 5G, on the other hand, there is kind of modular structure where you have the hardware resources, which are generic, and then we have softwareization or virtualization layer, and this divides the resources, splits them based on the requirements of the applications using these resources. And we have virtual network functions like EPC1, EPC2, and so on. So we have the traditional mobile networks, the old ones. They went through phase one, which is virtualization and cloudification, SDN, NFC, cloud computing. Phase two, service migration, like SDN at one, cloud factories, service migration. Phase three, orchestration of end-to-end orchestration of network and services. And phase four, service network automation, and phase five, using AI to automate the process of assigning the parameters and settings for the network on spot, real life. Key system components of flexible 5G deployment. We have distributed data center capabilities. We have enable edge computing, cloud orchestration with NFV, SDN, network and RAM slicing, and CID DevOps. And we have the SDN controller, like they are centralized servers that control the components in the network remotely. You have network devices, you have your base station, and this base station after that is connected to the 5G core. You have SDN service. You have SDN software-defined network uh, connected with switches and routers, which are virtual in the core of the 5G network. And we have DC gateway, we have that are connected to Internet of Things virtual network, voice network, UHD network, and all of them are virtual and providing different services, but common hardware structure. And the different services are enabled by using softwareization. So the main technologies here in the core of 5G technologies are software-defined networking, network function virtualization, multi-access edge computing, and network slicing. So up until now, this was an overview about 5G. Here, the evolution of mobile network security landscape. Now, starting from this slide, we gave you an overview. Now we'll start talking about just the security landscape in 5G, network security landscape. So we have the application in different generation, like 1G, the mobile generation 1G from 1970 to 1980. Each 10 years, we have a new generation, basically. Here, 1980, 1990, 2000 something, 2010, 11, I don't, but like normally, every 10 years, we have a new generation in networks, not in devices, in networks. And in 1G, the main service was voice. The 2G, the main service was voice with text. The 3G, voice with internet, but slow internet. 4G was voice with video with high-speed internet. And 5G connected world for all types of devices. Let them connect to the world. Let them connect them through internet. So what are the security threats that we need to take care of or be aware of? We have the physical eavesdropping fraud, we have the spam, rogue base station, we have the viruses, spywares, malicious apps, we have the mobileware, the ABT, the DDoS, the cyber warfare, the espionage, critical infrastructure theft. Like these are the main mobile network security problems that we usually face in the 5G network. Some of them are common to, of course, uh, computer networks in general, and some of them are more specific to the components that are used in the 5G system. So, composition of 5G security, you have pre-5G security issues, then issues related to network softwareization. For example, network softwareization is something that was not existing in the previous generations, like 3G, 2G. So, with this new concept, new security concerns arise. Issues related to new technologies, issues related to new verticals. The pre-5G security issues, 5G will be vulnerable to pre-5G attacks. So this slide says that there were some attacks related to previous generations. These attacks are still applicable to 5G, and they can be listed as follows. We have the mobile-aware attacks such as denial of service, botnet, APT attacks. We have the physical layer attacks such as jamming the signal, interference, eavesdropping, and man in the middle. Roaming frauds and IP hijacking attacks, rogue base station attacks, MC catcher, intercept mobile phone traffic and tracking location data of mobile phone users. And we have attacks via non-3GPP networks such as Wi-Fi, WiMAX, CDMA, WLAN. Now, these are the security issues related to network softwareization. Since you have open architecture, the open architecture introduce more attackers, no implicit security due to the lack of know-how. Software-based systems are easy to hack than hardware-based system. No premier security or physical security due to virtualization, first deployment of virtualized element with omitted proper security testing. So all these issues are related to the fact that 5G is using network softwareization. And this is the new technologies introducing new vulnerability concept. The new technologies that exist in 5G, which didn't exist before in the previous generations, are software-defined networking, network function virtualization, multi-access edge computing, and network slicing. All these are new technologies that were not studied comprehensively from the perspective of security, and attackers are exploiting some of these features in order to break into the 5G system. So we can stop here for today's lecture and continue later on. But these are mainly main the main theme and main topics that will be discussed in the 5G security landscape. Any questions? Any comments? So we can stop here